One of the best questions that I received in the Google form was, why do we need to learn maths if I can directly call the model dot fit directly? This was one of my favorite questions because this was the same doubt that I had during when I was studying machine learning. Now, I would like to explain with this an example. Imagine that you are a data scientist working in a very, very big firm X, okay, and your firm, uh, like it supplies some units, any type of products or units to some locality Y, okay, and they take the orders from another manufacturing unit Z, okay. This is the scenario, and you are the data scientist, and your code runs each and every day during the night from 12 a.m. to 6 a.m. And what is your code doing? The machine learning code that you wrote as a data scientist. It's predicting the demand of products, the demand of units in locality Y every day. Because you have to make the order in the mornings. So in the night, your code is running and predicting based on the past information that how much parts this locality Y on a particular date is going to have. Now imagine a special scenario arises that due to some function in the locality, due to a certain function being organized in the locality, it can be a marriage function, for example, the number of parts to be sent to the Y tremendously increased from 100 to 100,000. Now, what was your code doing? If your machine learning code without any EDA, without any study on the data, without anything, you directly called model.fit. This model could be supported to machine or deep learning model, anything. We just called fit on X and Y and called this method model.predict. Now, the data on which the model was trained was pertaining to this 100 units daily, right? Someday 100 units, someday 120 units, someday 300 units, but not exceeding 500. On a certain day, the demand increased, the demand surged so much that your model could not handle it. And still it was predicting order 500 parts at max because it was built to cover up or built to study the data based on around 500 units. It could never capture the information which was exceedingly greater than 500. Why? Because you did not do any EDA. You did not apply any maths. You did not see that what type of distribution currently the units are going and what might occur in the future. Because you did not take into consideration skewness, kurtosis, did not take any consideration of the probability density function of this distribution, the marginal density function. You did not see anything about this. And since you did not do any EDA, your model failed overnight. And you ordered 500 parts, and the actual requirement was 100,000, and you lost a major customer. Now, what did you learn from this? Whenever a problem arises, you cannot like if when this problem arose, what will you do if you didn't do any EDA? Will you change the model? No, it will still give the same results. And also the model already been trained, so you cannot change the model. What can you change? The way you doing the EDA, the way you understood the data, the way you map the probability density functions. This is what you can change now overnight. So this is why using model.fit directly is never beneficial. You have to understand the maths behind it. You have to understand the pattern in the data behind it. Because whenever a problem arises, you cannot just recall the model or change the model. You have to change the EDA process. You have to change the maths process. That's why the learning maths is important.